Okay, so all of you know that linear algebra is important right now. Okay, an image can be expressed as a matrix if you want to do computer vision. If you want to do language, natural language processing for AI, you express words at vectors, right? Um, so linear algebra is important. So and linear algebra can be expressed as mathematics of vectors. A matrix is nothing but a collection of vectors. So how is a vector? How is this data points? All the data points are expressed, as I said, it's stored in computers as in Python actually as a data structure, and the data structure is called list. So let's say you have v a vector and you save it as like this. Okay, that's how you store it. You can also make it another dimension more, and you can just print this and it will give it to you like uh, the vector. It's very simple. It's called a list. Now, what can you do with a vector? Um, that's the whole question. What is the whole idea of a vector? What can you do with a vector? And that's why is it called linear algebra? Because you can do linear operations. So you can add two vectors, you can add subtract two vectors, you can multiply a constant with a vector. It's like scaling a vector, right? So let's understand it and let's see. So if let's say you define v1 is equal to 1 to 3, and okay, before I go ahead, the next part will be what does the length of the vector mean? So if you define d as length of the vector, it means the dimension, the number of dimensions it contains. Okay, and you can also print d, and it's nothing but it'll give 4, the below one, 4. Okay. Now the next natural question is, can we add two vectors? So v2, if you can do it 2, 3, 4, and or you can just add these two vectors, and you can just print v. Can anyone tell me that? Sorry. Can anyone tell me what will be this v? Any idea? What will be this v? I have not printed out yet.
357.
Okay, and it's not. It's not this. So exactly, Shubhajit. Now, why is it doing? The reason is this, because right now Python doesn't know that you are actually storing in integers or you're storing in something else. For example, you can also store it as let's say a string. Okay, and here you can just keep it the same and let's see what it gives. So you can see what it's doing. What is it doing? It's concatenating to the two vectors. It's placing two vectors together. Now, why is it doing this? Because it doesn't know right now the list, it has numbers or not. So we have to make it, we have to make it conscious enough. We have to make it aware that it's actually adds element by element. So now this is also one of the most important reasons why we use NumPy. So NumPy, the library NumPy in Python, actually incorporates all this mathematical consciousness into vectors. Okay, we will talk about NumPy later on, probably in the next video, not today. But I'm making you aware what it means. So how to make it happen? How to add it? It's simple. That's why you understand algorithms, the algorithm to do it. So how do you do it? Um, let's get started. So let's say you have the same v1 is 1, 2, 3, and v2 as 2, 3, 4. So what you have to do, we have to define a new vector. Okay, which will do what? We will take the first element of this, the first element of this, and add them together. This element of this and this element of this, and add them together. How to do it? So you have to do a for loop. A for loop is nothing but it will take it over all each of the individual elements, and then add it. Okay, just um, yeah. So let's see how to do it. For I is the index in. Now this is where it's a sequence, right? 1, 2, 3. So what do? You do range. So range is nothing but it's a sequence. When you say range of 5, and you okay um, okay, it's actually given as it in a different way, but when you say range, it's stored in a dictionary format, and but when you say range, it means 0 1 2 3. Okay, so when you say 5, it means 0 1 2 3. It's I is iterating to 0 1 2 3 4. So what you do is you want to like iterate till how much? Till the length of the vector, right? Now both of them have the same length, so we are being able to do that. So you allow it, you allow I to range over the length, and what you do, this is where you have to define, this is where you have to define a new vector which will be the final vector. So v you define as something, so we define as none. It's nothing, like it's um, a data which says it has nothing, and you multiply it till, for how much length? For the length 3. So multiply it's, so essentially if you print this, you will get this. Okay, yeah, I think here is v1 is this, so we have to do it here. So you can see v is now none, none, none. That means it's a length, it's a non-vector of length 3. Now you iterate over this length 3. So now in the first iteration, I is 0, right? Now I is 0, and for that, what you will do? Okay, we will do it before this. I is 0. Now what you do, you define that the ith element of v is nothing but the ith element of v1, exactly, very good, Shubhajit, plus ith element of v2, right? And this will give v. Very good. Yes, you can do that. You can do it in many ways. Okay, I am doing it in the approach so that people learn it, the can see it, but there are easier ways to do it. Okay, you can just write a for loop in a single line too. I'm not doing it, I'm with the intention that people are learning it here. So now if you do print v, you will see a different v now. Okay, it's added that you have said. So what we are doing here, we are making it aware that how the addition is happening coordinate by coordinate, right? Now let's say it's a function, right? It's a binary function. It's taking in two vectors and giving out another vector. So can we make it into a function? A function takes in some input and gives some output. So let's make it into a function. So what we'll do, we'll define a function def sum. The two parameters are v1 and v2. Okay. Now for that, we are defining inside the function this none vector. Without this none vector, the people will not know that, like, the computer will not know where to add and store the things, right? Now the vector is v is defined. Now if you don't return here, so you have to return the output. Now you return v. So this v takes in v1, this sum function takes in v1 and v2 and returns v. Okay, so what you do now, now you print sum of v1 v2, and it gives you this output. Okay, the same thing. But what you have learned a few things. You have learned what are lists. Okay, this is a list, and a for loop, how to incorporate a for loop, and also how to define a function in Python. Okay, and we are applying it to define the sum of two vectors. Okay, next, now as a homework, you can do minus. Okay, you can do minus. You can someone tell me what this will this become? Probably, yeah. Okay, let's not do that. Okay, so now this is the difference. Okay, difference. So you can do this at your home, and if you similarly, you can do the scaling thing. Okay, you can scale a vector. How do you do that? Let's try to do that here. So let's say you want to scale a vector. Okay, so def scale. Now if you want to scale, what do you need? You need a single vector v and the scaling factor a, right? Now again, you define v as so you can keep the same v there. to save memory so that you do not have to define another vector there. Okay. So you define the same, you want to update the same vector. Okay. So the ith place is updated by what? Is updated by a times the current ith place, but you have to run a for loop. Where is this I? I is the index, right? Let me add a bit of all. So you do a for loop. You're running to the index in range of length of v, right? And you update this. Now it's already updated. Now you return v. So the function is done. Function is taking a vector and the scale of the vector. And now we need to define the v. Let's say v is 1, 4, 5, and a is 5. And do print of scale of v comma a. And you can see everything is multiplied by 5. Okay, so now you can also define it like you can define another vector w, which is none, okay, times length of which is multiplying the length, and you can add w here. But what it will do, it will nothing, it will just waste the memory. It's also stored, right? Where's the memory of this vector w? Okay, so we are not doing that. We are directly doing that this way. Okay, so I hope all of you are very clear with this understanding of scaling and subtraction and summation of vectors. So this is what vectors are. And now what you can do as a homework again, you can do a linear combination of a vector. Okay, so you can do def linear combination. And for a linear combination, you need how many things? You need input 2 vectors and the corresponding a1 and a2, right? a1 and a2 can be any real numbers. So now what you do, now you define a different v vector, okay, as as none into length of v1. So now you run over each of the index, okay, you run over each of the indexed, and now what you do, for any index, it will be nothing but a1 times the linear combination, right? a1 times v1 plus a2 times v2. So a1 times v1 I plus a2 times v2 I. This becomes a linear combination, and then you do the again return v, and you so v1 is already defined here. Let me bring them down. Okay, and a1 is, let's say, 1, a2 is -3, so we can print. Okay, why is there a yellow sign here? Because a2 is not defined yet below, or yeah, probably that's reason, because a1 is defined before. So let's see, you can do linear combination of this v1 v2 a1 a2. Yeah, and there is some syntax error. Oh, okay. So yeah, I hope all of you got it right. And a2 can be a2 can be -3, like any real number. Okay, yeah, these are very easy things. Now the fun things come. The fun thing is coming. So this is basic vector space. So why it's called vector space, why it's called linear space? It's because if you do any linear combination of 2 vectors, it will be still a vector of the same dimension. Okay, so if you add 2 vectors in the 3D, and it will be still in 3D dimension. That's what it means. So it's a linear space. By this linear combination, it stays in the same space. That's why I called linear algebra. Okay, in mathematical, it's said it's closed under the operations of addition and multiplication with a scalar. Okay, now it's coming the fun part. The fun part is the next part is the matrices. Okay, let me see, it's matrices. No, let's try out. So I really like to do it step by step. So would you like to do dot product, norm of a vector, or would you like to directly go to matrices, guys? What do you think? So I was thinking of showing you how to do dot product of a vector. So I think a good exercise for you guys can be um, try to implement uh, norm of a vector as a function. So you input a vector, input, so define a function that input a vector v and output its norm. Okay. And I would also like to do another thing, that is the dot product of a vector of two vectors. So do you want me to do any of this, or do you want me to go directly to the matrices, guys? Any idea? What do you suggest, guys? It's for you. I'm doing. You can just write it in the comments. What do you want? Norm, dot product, or do you want to directly go to matrices? Do you want to see something out there? What happens? Yeah. Dot product? Okay, sure. I will listen to the people who say. Okay, so let's see dot product. So dot product is, again, you have v1, v2. So let's define this here. And you want to define dot product. So you're inputting v1 and v2. What do you want? Now dot product gives a single number, right? So you have v0. So you define something. Initially, you have to always initialize. No, why I'm not doing it none? Because you will understand it right away. So what you have to do? You have to take every v1, every element of v, like ith element of v1 and ith element of v2, and multiply it, and then add over all the ith elements. Now these are two loop operations. Can we do it in single one? Yes. That's the idea of recursion. Okay. So you do for I in, again, range of length of v1. Now if you want to be cool and you want to say, oh, since v1 and v2 doesn't have, if what happens if v1, these are called edge cases, and these are extremely important. Okay. If you do lit code style problem, these edge cases are very important, and you have to give this if statements. So if length of v1, so dot product can only happen if the two vectors are of the same length. So you say that if length of v1 is not equal to length of v2, you show an error. Okay, you return -1, let's say. That's usually the error thing. And if not, it will go to the next step. So v is equal to 0. So now you're defining, like, if not, then we can do dot product. And the final, let's say, let's call it dot. Okay. The final dot product, assume it's initially 0. Now what's happening? If you observe, you first multiply. You need to save the sum. You don't need each of the values. Okay. So for example, if you need 1 times 2 plus 2 times 3, you don't need to save 1 times 2. Okay, you just need 1 times 2 plus 2 times 3. So we will do it in a similar additional. This is called recursion. So for I in range, so what you do, you add, you first add, it's initially 0. So what you do, you first add the ith index, which is starting with 0. That is v1 of I times v2 of I. Now what happens? Since you need to save the sequential sum, essentially what we are doing is that we are first saving this, then we are first it's 0. Okay. Then we are doing 0 plus this. We are saving this. Then we are saving this. This plus 2 times 3. So we do not need to save this, all this. Okay. It's automatically getting added because we need the final sum. And then finally it's saving 3 times 4. Okay. This is what it's happening. So every step we are adding this. So we don't need to save v1i times v2i for each of the i's. We just need to save its summation. That's why this is making it easier. This is memory, because you can also save it and add it, but that will be slower. Okay. So now if you do return here, it will give a very bad error. So because it's still in the for loop, so you have to do return dot. All of you understood it? Understood it? Can you give a thumbs up, please, guys? Like this, if you don't know how to give. Okay, super. Okay, so now you can print dot of v1 and v2, or dot prod. Okay, I have forgot again a colon here, so it's 2. Great. So the person who said dot product, I hope you understood. Okay, Srijit has asked um, norm. So do you want me to still do norm, Sritha, or you want to try it? You can write in the text box whatever you want. Let me try the norm. It's okay. So let's. So we again have v is equal to, let's say, 1, 2, 3. We want to find its norm. Norm is nothing but summation of first coordinate square, sorry, square root of first coordinate square plus second coordinate square plus third coordinate square, and the square root of that. So this is almost like this dot product only, right? You need to save the summation, not individual elements. So we'll do it exactly the same way. So def norm of v. Okay, but the important thing is, how do you do square root and square? So again, we need to save the norm. So let's save n equal to 0. Okay, because we need to save the summation. So first we will save norm square. Okay, it is v1 square. Like if this is v1, v2, v3, we will do v1 square plus v2 square plus v3 square. That means 1 square plus 2 square plus 3 square. Okay, so again, for I in range of length of v. Okay, now all of you can see it. If not, I will zoom it in. And again, do the same thing. N is 0. We are going to do what? We are going to do here. Same thing here. We will do 1 times 1 plus 2 times 2 plus 3 times 3. Okay. Again, it's a recursion. It's the previous step is dependent on the past step. So n equal to n plus what? Vi whole square. So first it's 0. So it sums up the 0th position. Sorry, this. I'm again sorry. Okay, but this is the norm square. So what do we do? So a to the power b is represented a star star b. So we do n equal to n star star 0.5. So it's now to the power half, right? And you return n. Print norm of, you can see that, because this is, I think, 1 plus 4 plus 9, 16, or 13 or 14. Yes. So of course the square root will be less than 4, because 4 square is 16. So it's 3 points, so which is right. Okay, all of you got it, guys? Yes, Shubhajit. So this is the thing. Yes, so okay, I agree also. That's a very good way. Shubhajit has said that you can also def norm as nothing but, very good, Shubhajit, thank you, as you already did this. So what we will do is, instead of this, we will do dot product of v1 comma v2, v1 comma v1. That means this is norm square. N is equal to this. Very good, Shubhadev. Very happy that you said this. Right? And you can also define return. So you see, this is, you are using a previous function to do this function. That's why it's very important. Okay. Thank you so much, Shubhadev. Yes, this is why I like talking to the people in the class, because sometimes teacher misses something important and the students say that. So thank you for saying that. And you can do print again. Let's do it norm 1, because we already defined norm 1 before, and you can see it's given. Oops, am I doing some mistake? This shouldn't have happened. Am I doing some mistake, guys, here? Okay. Let's see. No, doesn't. Ah, yeah. Because we have to do the n finally after this. So I did it in the last step. Do you see? So now it will give yes. Do you get it, guys? Where did I make a mistake? All of you, can you give a thumbs up? So this is why I like live classes very much. You can actually understand what's going wrong, and you will decipher the mistakes, because mistakes is a part of human life. Okay, super. Because we are doing the n, the square root side, the for loop. Actually, it was happening for each one of them. Okay, and it was adding that. So that's why it was actually what it was calculating here is nothing but okay, the last, yeah, it's a square root of v1 like this. Okay, it's very interesting. It's like there was one problem like Ramanujan gave, but yeah, anyways. Okay, so all of you clear with this basic vectors, guys? We can move on to matrices now. All of you good? Can you give a thumbs up? All of you good? Very good. Okay, so let's go on to matrices now. So we have done vectors and its introduction. Now let's go on to matrices. Okay. So what is a matrix? A matrix is, this is where very interesting things happen, and people usually miss this while learning. So it's my duty to tell you guys. Okay. So what is a matrix? A matrix, if you observe, it's a matrix. It's a 2x2 matrix. So you can represent the matrix. This is very important. You can represent the matrix in a column view and a row view. Okay.
So like maths, where it is.
Shivam, would you mind muting yourself? Because when I will ask you to ask you a question, please ask. Otherwise, it disturbs the flow. Okay. But I appreciate you asking questions. Don't think I'm not appreciating it. Or you can write it in the comment box. I can address it after I finish it. Okay. Okay. So matrix is nothing but you can express it as rows. For example, if you like 1, 2, 3, 4, 2, 3, 5, 4, 5, 6, 7, 8, 9, like this, it's a 4x3, 4 rows and 3 columns, right? So you can address it as like vectors like this, a collection of vectors like this, or this is called a row view. Okay, or a collection of vectors like this. 1, 2, 4, 7, it's a column vector. 2, 3, 5, 8, and 4, 5, 6, 9. So these two are very important. Okay, and these two have very specific interpretations that what is the important, like Gilbert Strang has really focused on this in his first lecture. So go back and watch his video. Okay. So if you look into row vector, row view is nothing but solving linear equations, and column view is nothing but finding basis vectors. Okay, or rather finding the solution of span, which I will explaining later on in the next class. But this is very important. Okay, so go back and watch the first lecture, geometry of linear algebra lecture of Gilbert Strang. You will understand a lot. But as I'm saying that a matrix can have two views, because it has two dimensions, right? So a collection of row vectors or a collection of column vectors. Interestingly, in Python, it is expressed as a collection of row vectors. Okay, and people have left it without thinking that they know it, but I'm sure they are not conscious of it. Probably they know it. So there are many things to be learned, guys. Even if you think I know Python, Okay. So a 4 cross 3. So it's Python. It saves the matrix as a list of lists. Okay. A list of lists. Okay. So this is nothing but a collection of row vectors, guys. And this is what the matrix is. It's the list of list. This is very, very important. Okay. Um, so matrix is a collection. Okay, I am making, actually I'm writing a book. So as you can see, where all these things will be written, so that you can learn here, guys. So you can see I have written these things here. Okay. So that's why I'm testing my ideas on you guys, whether you understand it well or not. Okay. So M is a matrix here. So now what does it mean? There are various things. Okay. Can someone tell me what does the length of M? So M is a list of lists, right? A list of row vectors. So what is the length of M? Can someone tell me? Is it the number of rows or number of columns? Quickly. No. It's the number of rows or number of columns? Number of rows or number of columns? No, not the number, guys. Try to understand. Let's say you're given a list of list. Perfect. It's a number of rows because it's a collection of row vectors. Very good. So n is the number of rows. And if you look now here, if you add one number here, this is not a matrix anymore, because each of them doesn't have a same, each of the inner, so I call it outer list and inner list. Each of the inner list doesn't have the same length, right? So now it has same length. So how do you find the number of columns? Since all of the inner list has the same, this is how you access a list element. How to access an element of a list? Let's say you want to access the length of this. So you go to M, you can go to the first 0, because everything starts with 0 in Python. First 0 and length of that, because M of 0, the first list, the first element of the bigger list, the outer list, is itself a list, because the matrix is a list of row vectors. Okay, so the first row vector length is number of columns. All of you got it, guys? Can you give a thumbs up? This is very important, guys. Okay, this is overlooked a lot. This is how you understand very fundamentals of what exactly is happening. Okay, and this is something you think. Got it, guys? Very good. So you understood what is a matrix. Now let's say I ask you a question. Okay, so I want to do it problem by problem. Let's say now you want to understand matrix multiplication. Okay, matrix addition is really easy. Okay, let me start by matrix addition. So we have two matrices, let's say same dimension. Let's say I change a few. Two matrices, and I want to add it. The same process happens again here. Def I think it's better if you do it, but let me try to do it in front of you, because there'll be two for loops. So def add. I would suggest you to do it again at your home. So for I in, understand it. So there'll be two for loops. Can you tell me what will be the two for loops? Can someone tell me? What will be the two for loops? For I, understand this very carefully. Okay. For I, yes, exactly. One for row, for one for column. That's how you access the rows and the columns, guys. Okay. That's what I mean. This is very important. Okay. That's how you access the rows and the columns. That's why I did it first. Perfect. So we already did it like this. So in range of length of M1, because both are the same length, same dimension. So what is it doing? This is nothing but running over the rows, right? Again, now for each row, it will access each of the column element. So another for loop for j in range of length of this, right? Now it's accessing, it's running over columns. Now now we have got each of this is a representation. So how do you represent a matrix? A matrix is nothing but mi comma j. Okay, and I is the row element and j is the column element. All of you got it, guys? This is very important. This is a mathematical representation of a matrix mi comma j. So now what you do? You have to define another matrix. Okay, how do you define another matrix of that same length? Any idea? Yes. You define it the same way. Okay, so how do you do it? You do it, in that case, you did it with respect to, if you remember, none into the length of the vector. In this case, you have to, let's define a none vector of m1, okay, of same length as m1. I don't think it's necessary here, but okay. As of now, because it will, I'm just, we are out of time, so let's not, because it will again be nothing but adding none in each of these. Okay, so what we will do, we will just define another 0 0 here. Okay, doesn't matter. So actually you have to replace all of them. So this is the final matrix that we need to, and that we need. So we will define it inside this. Essentially, you have to define something out there, initialize it. That's what I mean. So now m of I and m of j. Okay, this is the ijth element. So this is first selecting. So just m of I will be okay. So let's go back to a bit of basics so that you understand. So what will be m of I? Or let's say m of 1. M of 1 is nothing but the second element, the second list. Okay. And now you want to access this element. So m of 1 is nothing but the second vector, second row vector. So this is the ith row. Okay. So if you do m of I, it's the ith row and j is the column. That's what I wanted to make you understand. So now if you want to print m of 1 comma 2, that means is the second element, sorry, the third element, because everything starts from 0 here. The third element of the second row. So this will be nothing but the 5, right? This. So this is, so mi comma j is, let me write down here, is the ith, is the element in ith row and jth column. This is something you should be very clear. And so that's why it's the ith row and jth column. Okay, you just add them. Sorry, it's very easy. The main learning point was this, guys: how to access the elements. Okay, what does it mean? And then the for loop. The other part is easy, right? And then you can add it. Can print add m1 comma m2. I hope I didn't make any mistake. Yeah, it's all adding up there. Okay, so all of you got it, guys? So the main part, as you can understand, is the learning part is this: what is the ith and jth element? All of you got it, guys? Can you give a thumbs up? And then the for loop out there. Okay, this is very, very, very important. Very, very fundamental, very, very important. Okay, so now next day probably we will do, um, I think it's already time for today, but you think for the exercise as today, so next day I can do it tomorrow, I don't know, it just randomly comes to my mind and whenever I have free time. So next day what I will do is, you think about, and we will see an interesting, so I am asking you an interesting question here. How can you change one element, sorry, the row view to column view? How can you change the row view to column view? So we want to change it. Okay, I have removed it. So I want to now express this 1, 2, 4. So the goal is, the following. I want to represent this as this 2. So let's call it M row view, and now I will represent M column view, which will be represented as, which will be a list of column vectors, which is 1, 2, 4, 7, comma 2, 3, 5, 8, comma 4, 5, 6, 9. So I want to change, so goal, change, define a function that changes M row to M column. Any guesses what this operation can be, guys? If you know linear algebra? Any guesses? The matrix. Very good. Exactly. This is nothing but transpose of a matrix. Okay. So next day we will do this transpose of a matrix. This is beautiful, right? This is very beautiful. But the thing is that so the most fundamental thing that people get stuck at is not coding, but it's actually mathematical representation of the elements in coding. So the thing is that if you want to do a transpose from scratch, we know what is a transpose visually. Okay. And with that assumption, we apply it in our user libraries. But what does this transpose mathematically mean? That is where the real learning and conceptual understanding is. For example, a transpose is nothing but taking the mijth element, okay, and replacing it. So if you call mt the transpose, it's nothing but the ijth element of mt, the transpose is nothing but the jith element of m. Okay, so this is the main representation that one needs to understand. So whenever you see a transformation of a matrix, is nothing but a mathematical operation of each of mij. Okay, that's it. So next day we will, or you can do it, and we will show this. You know why I am saying that this m column view is important, because when you do matrix multiplication, let's say you want to do matrix multiplication of m row and m column. So what you're essentially doing, if you understand, if you want to do m1 and m2, okay, if you want to do m1 times m2, you're actually, and you want to find this new matrix. Okay, so why this is important? Because if you want to matrix multiply, let's say m as m1 times m2, what will happen is the mij is nothing but the dot product of ith row of m1 and jth column of m2, right? So that's why here it is not possible, because the length are different. But if two matrices are, can be are dimensionally dimensionally can be matched for multiplication. So that's why we need to access the row as a vector. Now once we access the first row of this, and we change the second matrix into a column form, so therefore we can access the rows. So we need to access rows of M1, and we need to access columns of M2. Okay, we need to access the rows of M1 and columns of M2, and then do dot product. So now it's an easy for loop. Now that's why we need to transform that. So essentially, when you do a transpose, each of the vectors become a column. Okay, then you can access it in this form. Do you see why I'm saying this column view is very important? So next day we will do this, and we will move on to other advanced stuff. So this is the basic idea that we will do next day. Okay, guys. So I hope you enjoyed this, and I will see you in the next video. Any questions out there from your end? Any question?
Hello.
Yes.
Yeah,
please go ahead.
Can we just do the transpose by just swapping the off-diagonal elements Aij and Aj?
Sure. You can do it many ways. Okay. Yeah, you can just, as you said, we can swap the off-diagonal elements because the diagonal elements don't change. So you do for I in length this, j in length this, if I is not equal to j, and then do the swapping. Exactly. So that we will do next day. Okay. Today we don't have much time left. Any more questions, guys? Is there any other way I can help you out? Yes, we will give you the recording. I hope you enjoyed it. Give a thumbs up if you have enjoyed it, and I will get back to you soon when I get some time. Okay. I hope you learned something that you didn't get in YouTube videos. And bye-bye, and have a beautiful day ahead.